Alright guys, let's take a look at this key. So it's going to be broken up into a couple parts. We'll do the front page separately from the proofs on the back, just because even though they're similar, they're different beasts. So before we get into these 9 problems, please know that we are always searching for one of 4 things. In terms of proving triangles congruent, the shortcuts we've established are going to be our main focus. And so just as a quick review of the 4 conditions we could meet, if we ever see 2 triangles that are matching certain pieces of information, we know that we have congruency, but it's important that we pay really close attention to the orientation because the orientation is going to be the key to knowing whether we are meeting a condition or not. So really quickly in review, if this one's probably the simplest one, if in both triangles we realize that all sides are congruent in pairs, we know we've met the side-side-side triangle congruency theorem, and therefore triangles are congruent. If we ever have a situation where we have 2 sides, and in between the 2 sides we know an angle, this of course in both triangles, we've met the side angle side triangle congruency theorem. Okay, and again, the whole idea of these shortcuts is if we know the side angle side, we don't have to prove the other information because it must be the same in both triangles, if this is. Please note in side angle side, we call side angle side because of the order. We have a side that runs into an angle that runs into a side, just like the name implies. Another combination of information we could use would be angle side. And again, please note if we're talking about angle side triangle congruency theorem, we have an angle to a side outside of them, so angle side. And another combination of 2 angles in the side would be ASA, angle side angle triangle congruency theorem, in which we have an angle, another angle, and a side trapped between them. So that's what we're going to be searching for in this homework, for the 2 triangles that are pictured to somehow meet this information. We're going to have other things in play as well, like those 2 sheets of facts that take a structure to a relationship. We're going to be looking for those as well. So let's just get into it. Let's see if we can work this out. So let's check out this first one. We have these 2 triangles, and the first thing we should note is that we have some information right off the bat. I'm seeing a pair of sides here and a pair of sides here. So this immediately tells me I'm either going to go with side congruency or side angle side congruency. And it turns out I can probably actually do both. So if I'm looking for side, I can say, well, look, this third side in the middle is going to be congruent in both triangles, top and bottom, because of reflexive property. And therefore, I have my side, congruency. Alternatively, and I'll do this one in pink, I could notice that the entire triangle is an isosceles triangle. And if it's isosceles according to the base angles biconditional, if I have isosceles, these angles are all automatically congruent, and I'll record that as base angles here. Now, I'm not requiring you to find all of them, but I do want to point out, like, this is the nature of proof. Like, sometimes it's more than one way to do it, and so we have to be aware that both are equally good. It's just depending on which one you want to pick. Either way, now that I know they're congruent, I need to write a congruency statement. I'll go ahead and use side congruency here just for convenience. Now, I've been provided a congruency statement, but this one turns out to be false. The reason being, if you look at the order IHJ, that goes IH down to J, but JHK does not. It goes just in the wrong order. So this one turns out to be false. Several of the congruency statements here are false. So I have to kind of write my own. Now, it doesn't matter the order, so I'll just go ahead and pick IHJ, and I'll make it congruent. If we look at IHJ, it'll have to be triangle KHJ. And I do need to name why I know it. Now, I'm not going to name like reflexive or base angles. What I am going to do is use a triangle congruency shortcut that I end up meeting, and so this will be because of side triangle congruency theorem. So I know during class several people kind of called out that this should be congruent because of reflexive. Reflexive doesn't prove congruency. These prove congruency. Where are they? There they are. These are things that prove congruency. Reflexive, base angles, 2 lines cut by a transversal. Those are things that help us find the pieces we need. But in the end, if I'm proving triangles congruent, I have to use one of those the shortcut conditions or the main definition of congruency. Okay, so we have ABC congruent to DEF. Let's check it out. Let's first check out the order. ABC, DEF. Well, that looks legit, so that looks like a good congruency statement if I do end up having one. Let's check out the information I have. Well, I have 4 is congruent to 4. I have 6 is congruent to 6, or I should say equal to 6. But then I have kind of this curiosity in the middle. Let me see if I can outline what I mean. So I'm told this part is 2, and I'm told this part is 2. But that's not the whole side of the triangle. But if I think about reflexive property, and I realize the middle is the same on both, certainly 2 plus FC should be the same as 2 plus FC going the other way. If you're not quite seeing what I'm talking about, let's give the middle a numerical value. Numerical meaning not a number in this case, but a variable. So let's say the distance between here and here would be x. Well, that would mean this whole distance for the upper triangle would be 2 plus x, and then the bottom distance here would also be 2 plus x. But in the end, those values are the same. So this one turns out to be true as well. Yes, they're congruent. So let's write it. Triangle ABC is congruent to triangle DEF. And we use side, side, side triangle congruency theorem. Okay. Oh, we didn't name the property here, so let's go back and do that. I would say we use a little bit of reflexive property. Okay, and then we use some addition. Okay, now I know addition isn't something that I named on our sheet, but if we were to go through and name every possible theorem, definition, property, we do that for like the next 4 weeks. So it's important to note that if something pops up that's not on the sheet, that's totally okay. You just have to be able to name it as like a definition or a property. In this case, we're just doing addition, so it's okay just to say addition. Let's move on to this one. So we have these triangles, ABD, so A, BD, and CBD. So we're not worried about the names right now. Let's just see if we can meet any of the conditions. So right here I have a side, go to a side. I have this angle. Now that should mean because of supplementary, definition supplementary or perpendicular, that one is right as well. So I do have an angle on both sides. I do have a side on both sides. Now I could use reflexive and call that one the same as itself because it's shared. But I'm looking at this, I don't think we can prove anything else. In fact, I don't think this even proves congruency. Here's the reason why. In the ABD triangle, we have side, angle, side. So this one is side, angle, side. But over on this one, I have side, side, angle. So this one is side, side, angle. Those aren't the same information in both. It doesn't match in both. I don't really have a way to prove that the third sides are going to be the same. So this one's just a flat out no. I could use Pythagorean theorem, but the sides that are left in both are not the same side. So this one's just a flat out no. We don't have the information to prove it. And that's okay, because I didn't say you could prove these all. I said to ask yourself if you could prove them. Moving on, let's go to this guy. So first let's evaluate what we have. So I have a side in both, an angle in both. Now the keen-eyed among us might realize that this is going to be a third side. So that's going to give us that. And so I wonder if I can find anything else. I can't really tell anything about angles or side length. I mean, that's all the information we have. So let's take a look at what we do have. I have side, side angle, and I have side, side angle. So the information, unlike the last one, is matching. But it turns out like this is not going to help us because side, side angle just doesn't prove congruency. I have a strong feeling the way it's drawn that it probably will be congruent, but I lack the information to actually prove it, so this one's going to be a no. Alright, A, B, C, D, E, F. So A, B, C, D, E, F. Yeah, the order seems to be okay. Let's check out some information. So we have a side, we have this angle, and we have another side. So it seems to me we don't have to do any more work. I'm looking at side, angle, side, triangle congruency. Side, angle, side on both. So I think we're ready to go. The congruency statement as written seems pretty good. It seems in order. So I'll just use it. ABC congruent to triangle DEF. And this is going to be because of side, angle, side. Triangle congruency theorem. Cool. Let's move on. That was quick. TSU KJL. So let's check it out. TSU KLJ. Okay, the order's wrong. So that should be KJL if it turned out to be congruent. So let's check it out. I'm seeing a side. I'm seeing an angle. I'm seeing a last side. So it looks like I do have angle, angle, side, triangle congruency, angle, angle, side, triangle congruency. So we're good to go here. I've already kind of fixed my congruency statement. So TSU congruent to triangle KJL. And this is angle, angle, side, triangle congruency. All right, let's move on. We're rocking and rolling now. All right, let's first check a congruency statement. So WFL, WYL, that checks out to be okay. Let's see if we have information enough to prove these are congruent. I do see that those are an angle. Boom. We have a side. Now, let's see if we have anything else. So we have angle, side. Here we have reflexive. But it looks like we're kind of in the same boat as we were before. I'm looking at angle, side, side congruency. Angle, side, side congruency. So this is going to be a no. Not enough to prove. All right. So here we have a perpendicular, which means that angle's got to be right angle as well. We have an angle and then a side. I think we're good here because I'm looking at angle, angle, side, and then green, pink, blue. Yeah, so that's going to work okay. Let's see if our congruency statement's right. K, our HKN, so H, so pink, up to nothing, down to right angle. LGN, pink, up to nothing, down to right angle. So that looks like it's going to be correspondingly written. So we have triangle HKN, and that's going to be congruent to LGN. And in this case, it's going to be by angle, angle, side, triangle congruency theorem. The last one? Oh, this is the last one. All right, let's go. So again, let's first check our statement TNS. So T to the rightish looking angle down to S. UHS, that's going to be the same. So this is okay as written. Let's just see if we have the information now. So we have an angle on both. We have a side on both. If we need one more piece of information to actually make this happen. But it looks like here, I have a stroke of luck, we got some vertical angles. So that's going to be the vertical angle theorem, or VAT for short. Okay, it looks like we're going to meet angle, angle, side, triangle congruency. So TNS congruent to UHS by angle, angle, side, triangle congruency. Okay, so that wraps that one. And so again, the thing to glean here is that we are just looking for matching information. Once in a while, we'll have to do a little extra work to find the stuff we need. Sometimes it's going to work out for us where we can prove congruency, and sometimes we can't. So there are a few here that we couldn't do. If you think you need some more help on this, we'll talk in class. Also, there's some more practice on the Google Drive. So that's another source. Like if you just want to look at some more triangles and try to figure out if they can be congruent, that's good practice. That's something that's on the Google Drive. It's there for you. Please help yourself. So that's where this video will stop. We'll talk now about the 4 proofs.